We continue with HSC 2019 Extension 1 Mathematics, Question 14 C, Part II. We already done Part I, which we proved cos x0 is equal to cos x0 minus alpha. What we had in that question was two graphs, the red graph and the blue graph. The equation of the red graph is y equal to sine x. The equation of the red graph is y equal to sine x minus alpha plus k. The two curves touch at x equal to x0, and the value of alpha lies between 0 and pi, and k is greater than 0. And in the previous part, we proved that cos x0 is equal to cos x0 minus alpha in the previous video. Now we are proving that sine x0 must be equal to minus sine x0 minus alpha. Starting from the part I, so from part I, we proved cos x0 is equal to cos x0 minus alpha. Now, we got to look at the condition when two angles have the same cosine values. There are a number of ways that this can happen. One is one angle be equal to 2 pi minus the other angle. Okay, so if one of the angles is equal to 2 pi minus the other angle, then you have equal cosines. That can be one case, or it could be other way around. It could be x0 minus alpha is 2 pi minus x0. Both of them are a possibility if we have two equal cosine values. If we look at the first one, we get from this, you get x0 is 2 pi minus x0 plus alpha. Then you take x0 to the other side, becomes 2x0 is 2 pi plus alpha. Then that gives us, dividing both sides by 2, x0 is equal to pi plus alpha on 2. But considering that alpha is a positive value and we're adding pi to that, but from the graph, we can see that x0 is between 0 and pi on 2, or actually they have told us, so not possible. Okay, so this is not possible, as x0 is between pi on 2 and 0. Okay, so this conclusion from that was not correct. Let's look at the other one, see what happens there. So again, if I take this to other side, I get 2 x0s, and I bring over alpha to this side, I get 2 pi minus alpha. Then I divide both of them, both sides by 2. I get x0 is equal to pi minus alpha on 2. And again, alpha on 2, because alpha is between 0 and pi, so alpha on 2 will be between pi on 2. I divide both sides by 2. Alpha on 2 will be between 0 and pi on 2. And when I take away 0 from, so the maximum value based on this that x0 can have when alpha on 2 is 0. So that gives x0 equal to pi, which again is not acceptable because x0 has to be between 0 and pi on 2. Or the minimum value I can get from here when alpha on 2 is pi on 2. So pi minus pi on 2 gives me pi on 2. and x0 becomes pi on 2. So that is the smallest value that this let x0 have. So then again, it is not acceptable. Okay, so not acceptable as x0 must be between 0 and pi on 2. And this equation gives values beyond pi on 2. Okay, so none of these assumptions were right, so they don't work. Then what do we do then? We come out with the other alternative, because you know that if one angle is the negative of the other angle, then also they have the same cosine. So we look at that scenario. So one of these angles like this is negative of that. So then we can say x0 is the negative of x0 minus alpha, or x0 minus alpha is negative of x0, which is basically the same. It doesn't matter which one you take. Anyhow, if we work out from here, we get x0 is equal to minus x0 plus alpha, so 2x0, if I take x0 to the other side, is equal to alpha, or x0 is half of alpha. And that should be working, because alpha is between 0 and pi, and then x0 will be half of that, which is between 0 and pi on 2, which satisfies this condition. Okay, so that is the relationship between x0 and alpha on 2. But what they are asking from us in part 2, show that sine x0 is equal to minus sine x0 minus alpha. Okay, let's look at the sine x0. Sine x0 will be sine alpha on 2. Based on this, sine x0 is equal to sine alpha. Now let's see what is the minus sine x0 minus alpha. That will be equal to minus sine x0 is alpha on 2 minus alpha, and that gives us alpha on 2 minus alpha is minus alpha on 2, if you take the common denominator. And then negative of a sine of a negative angle is negative of that the sine. So it becomes minus sine alpha on 2, which is the same as sine alpha on 2. Okay, so what we showed that both sine x0 is sine alpha on 2, and also minus sine x0 minus alpha is equal to also sine alpha on 2. So, as sine x0 is sine alpha on 2, and minus sine x0 minus alpha is sine alpha on 2, then we have that equality. Sine x0 is minus sine x0 minus alpha. That is the proof for part 2. Thank you for watching.